All right, question 2. Draw a point that belongs to the solution region of this system of inequalities. So they only want a point that makes both of these inequalities true. So of course you could take a guess at a point and substitute it into both inequalities and check it that way. But let's do this the official way. I'm going to start with the easier of the two. This one's easier because it is a line that is in slope-intercept form. And the slope is 1 over 2. And our y-intercept, our b, in this problem is -5. Couple things to note. We have a y is less than symbol right here. So this tells me the line is going to be dashed line and the points are open points. Now that's not super important in this problem because they don't actually want us to technically graph this line. They just want us to find a point that is a solution. But I'm going to go ahead and do it because it's good practice. So I'm going to start the y-intercept of -5 and I'm going to rise 1, run 2. Rise 1, run 2. We can do the opposite. So there is my line. Then I'm going to graph it. Just remembering that this should be a dashed line. And let's go ahead and just extend it a little bit further. All right, so this is a less than problem, which means all of the shading for this problem, or all of the potential solutions that make this inequality true, are below this line. So the point that we select is going to be somewhere in this region. But we need to narrow this down further by graphing this quadratic. So this, of course, is going to be a parabola. It's going to be a U, or a happy face rather than a frown face, because that leading coefficient is positive. So I'm going to sketch a really rough sketch of this by finding the vertex. And to find the vertex, we're going to use the formula -b/2a. This will give us the x-coordinate of the vertex. Remember, the vertex is this minimum point. So if we look at this problem, our a, b, and c are the 3 coefficients. So the a is 2, the b is -5. We don't really need the c, but I'll put it -3. So -b/2a is -5/2 times 2. -5 is +5. 2 times 2 is 4. 5 divided by 4 is 1.25. So the x-coordinate of the vertex is 1.25. I'm going to use the calculator to get the y-coordinate. And to get the y-coordinate, we're just going to replace wherever we see an x with 1.25. So that's, instead of 2x squared, it's 2 parentheses 1.25 squared. Minus, instead of 5x, it's -5 parentheses 1.25. And then -3. And this will give us the y-coordinate of the vertex, about -6.125. So a rough sketch of this, 1.25 and then down 6. Make sure I'm doing this right. It's going to be somewhere right around here. This is a y is greater than, so that means it's an open dot and a dashed line. And again, I could get more specific with this, but I just know it's going to look something like that. It's going to look something like that. And we want to shade all of the points that are greater than 2x squared minus 5x minus 3. So that's the points above this graph on the inside. But we only want where the shading overlaps or where the arrows pointing overlaps. So that's in this little region right here. So it appears, let me pick a dark point, appears about this point right here. That's not a good color. Right here. Appears this point right here satisfies both inequalities, but let's check. So the coordinates for that point are 1, -5. So let's double check and make sure the point 1, -5 makes both of these inequalities true. I'm going to substitute it into the bottom inequality first, just because it's easier. So I'm going to replace y with -5 and x with +1. 1/2 times 1 is 0.5. 0.5 minus 5 is -4.5. So then the question, is -5 less than -4.5? Yes. And we're going to check it again. For y is greater than 2x squared minus 5x minus 3. We're replacing y with -5. We're replacing x with 1. One squared times 2 is 2. 5 times 1 is 5. 2 minus 5 is -3. -3 minus 3 is -6. Is -5 greater than -6? Yes. So the point 1, -5, that is our solution.